And you can see our figure's having a bad day, but he is doing his best to get away from the night. Hello everybody, Yellow Mustang here again with another Roblox scripting tutorial. Today we're going to be making a figure civilian AI guy that runs away when he takes damage. This is going to be a fairly short, fairly simple, hopefully, tutorial today. So I just got this figure here and some zombies that'll chase him, and just using a normal R6 figure today. The script will work with R15 figures as well. Inside of him, we got the Roblox default animation script, and then, of course, my normal custom sound script that just plays sounds when he does the events, walking, jumping, dying, all those good stuff. And that's pretty much it to him. He's pretty generic. So let's go ahead and get the script going here. And we will name the script AI as usual, and then we're going to start off with our local variables as normal. So local myHuman equals script.parent, wait for child, humanoid. And then local myRoot equals script.parent, wait for child, humanoid root part. And then local myHead equals script.parent, wait for child, head. And then local myFace equals myHead, wait for child, face, lowercase there, face. And then we need some other variables as well, so we'll keep track of our health. So old health equals myHuman.health. Local fleeing equals false, so if he's running away, that will flip. Local flee length equals 5 seconds, so that's how long he will run away for. Local flee countdown equals flee length, so that's going to just be the variable we use to count down for the 5 seconds, basically while he's fleeing, running away from the danger. Local path count equals 0, so this is going to identify what path we're doing. So we're going to be calling the pathfinding function a bunch. We need to keep track of what path is being called, so this is going to keep track of that. This will make sense later on. Local dead equals false, so that will flip if we die. And then, as usual, our clone variable, which is going to be script.parent clone. First function we'll start off with is the get unstuck function, which is going to just get him unstuck if he is stuck somewhere. So it's just going to tell him to move in a random direction, essentially. Okay, so that will choose a random X and Z direction to walk to. And then also I like to have him jump to also help get unstuck, which usually works. And then we will have him walk this direction for half a second, so we won't delay it too long there. The next function we are going to set up is the path to location function. So function path to location, location as the argument there. And then so as usual, local path equals game, get service, pathfinding service, create path with default variables, because this guy's a normal size. And then we want to do compute async. Starting position will be myRoot position. Ending position will be location, wherever we tell it to when we call this function. And then local waypoints equals path get waypoints. And we'll do path count equals path count plus 1. So this is going to count up every time this function is called. So this function is going to be called multiple times on different threads. So we want to cancel previous running functions if we call this function again. So this is going to tick up every time we call this function. And the older threads that are still running this function are going to notice this number is different than before, and it will go ahead and break out of the pathfinding. So let's continue typing here. Hopefully I can make that make sense here in a second. Path.status equals enum.path status. So if we get a successful path, then continue, else the path failed and we will do something. But continuing on here, we'll do local current path count equals path count. So we will take note of what the path count is when this function was called on that thread. So if this path count changes, then we will be able to tell. So now we will go ahead and loop through the waypoints. So for I waypoint in I pairs waypoints do. Okay, and then we're gonna do if current path count is not equal to path count, then break. Okay, so every time we go to a waypoint, we're gonna make sure there's only one instance of this function running. So if this function is ran again, this path count will be different than the current path count, so therefore this loop will break and that thread will die. And actually we're going to use a return here to ensure that the thread dies, so we're not having too many threads running in our script. Next we're going to check and see if we need to jump based on the waypoint. So we'll do if waypoint dot action equal to enum dot path waypoint action dot jump, then my human dot jump equals true. So that will just have the human jump if we need to jump. Next we will have the human move to the waypoint position. After that we will do delay 0.5 seconds and then function, and then my human, let's see, we'll do a check here. We're going to do if my human dot walk to point dot y is greater than my root position dot y, then my human dot jump equals true. So this is going to essentially spawn this function on a different thread after half a second, and it's just going to double check that our root position is either equal with the walk to point or higher than the walk to point. But if we're below the walk to point, then we most likely have to jump. So this will just double check, because sometimes the Roblox pathfinding service does not tell us to jump enough and we'll get stuck a lot of the time. This is a good way of ensuring that we don't get stuck. And shout out to Kat in the comments section who suggests I use delay instead of spawn. Great suggestion. I've seen it before, but I totally forgot about it. Next we'll do move success equals my human dot move to finished wait. Okay, so this is going to pause this loop here until our human makes it to the waypoint. It will time out after, I believe, 7 seconds. If it does time out, then move success is going to be false. If we make it to the waypoint successfully, then move success will be true. Okay, so we're going to check if we don't make it to the waypoint. So if move success is false and we don't make it to the waypoint, then we're going to break, because the path is most likely no longer valid. Okay, so now we will check if fleeing is equal to true, then if I is equal to number of waypoints, then wander. Okay, we haven't created the wander function, but we'll get to that in a minute. So essentially, if our guy is fleeing away from danger, he's still within that 5-second cooldown that we have going, then we're just going to immediately, if we're at the last waypoint, then immediately just find a new path to run to so we don't stop in place. We're going to call the wander function, and that is going to generate us a random point to walk to, and then this function will be called again, and we will continuously move if we are fleeing. If we're not fleeing, this will be ignored, and then we will take a nice pause, and then the figure will begin walking at his leisure, basically. Next, if the path fails, then we will just run the get unstuck function, because we're likely in a bad spot if the path is failing. Next, we'll go ahead and create that wander function that I was speaking about a minute ago. So we'll do local rand x equals map.random negative 50, 50, and then local rand z equals map.random, negative 50, 50. Local goal equals my root dot position plus vector3 dot new, rand x 0 and rand z. So that is going to generate us a random point to move to based off of where our figure is standing, because we're basing it off of my root position. So we will move 50 studs in a perimeter of 50 studs away from our torso. Okay, so now all we gotta do is just call the path2 function and provide it the goal that we have found. And the wander function is good to go. Okay, easy enough. The next thing we're going to do is create a function to find threats. So function find threat. We'll do local distance equals 100, local threat equals nil. That's just a placeholder for when we do locate a threat, if we do. So now we'll do for IV in pairs, workspace, and get children, do. And we will do local human. So actually, let me explain this. So for IV in pairs is going to loop through everything in the workspace, and the object that we're on in the workspace will be represented by V. So just take note of that. Local human equals V find first child humanoid. So if the object we're on in the workspace contains a humanoid, then that will be assigned to the human value. Next we will do local torso equals V find first child torso. So we are also searching for torso. If we do not find a torso, we will also accept humanoid root part as an acceptable replacement for that. So if we don't find a torso, then we'll go ahead and check for humanoid root part. So now we will check if those variables are assigned or not. So if human exists and if torso exists and v.name is not equal to, actually we'll do this, if v is not equal to script.parent, then continue. So we want to ignore v if v is ourself, because we are in workspace, so therefore we will get checked. So we will ignore ourselves there. So let's continue on here. We will do if my root dot position minus torso dot position dot magnitude is less than the distance that we have provided, then continue. And then that will find a object in the workspace that is not us, has a torso, has a human, and is within 100 studs of us. Okay, so now the threat is most likely whatever is closest to us. So threat is torso, and then we will update the distance. We will do my root dot position minus torso dot position dot magnitude. Magnitude. Okay, it's hard to spell. So distance will be updated. So the next object that we find in workspace will have to be closer than whatever this one was. So it will go through everything and it will find the closest torso to us that contains, a humanoid and is alive and is not us. So when it's done running through all of that, we will return threat, and we will return threat whether it exists or not. So it's going to return a torso value. If we find a threat, it will return nil if we don't. So let's go ahead and carry on here. We will now create the flee function. So we'll do function flee, and we'll do local threat equals find threat, and we'll do if threat, then continue, and we'll do locals. So let me explain this before I get too carried away. So we are going to create a variable in here calling the find threat function here, and since we're returning threat will be assigned to this threat variable, basically. So you can do that as an easy way of passing variables from functions. If the threat variable is not nil, then we will continue here. We will do local cframe equals my root.cframe times cframe.new threat dot position minus my root dot position dot unit times 50. Okay, so this is going to find us a position based off of our root position and our threat position. How do I explain this? This is going to essentially find a point that so it takes my root C frame and then it finds the direction of where the target is from us, and then it shoots 50 studs away from that. So we are essentially going to run 50 studs away from the target, because threat.position minus my root.position.unit will give us the direction from us to the target, and then we will do times 50, and then we will times it by my root.cframe, and that will give us a C-frame value that is 50 studs in the opposite direction of where the target is. So we will be running away from the target, essentially, based on wherever we are in relation to the target. So that is a fairly simple way of doing that. Next thing we're going to do here is we're going to spawn function path to location, and then path to location, then we need the location we want to go to, and we'll use the C-frame dot position. And then in here we just need end. So this is going to call the path to location on a separate thread, so we can continue running this function and then run this function separately, so they can both run at the same time, because we want to be pathfinding, and we also want to have the cooldown going for our running away, essentially. So we will continue on. Hopefully I can make sense of that also. If we do not find a threat, but we're taking damage anyways, we will just run in a random direction. So now we will go ahead and set up the cooldown. Flee countdown equals flee length. Okay, so that's going to reset this flee countdown variable back to the flee length that we had set above, which is 5 seconds. And then we are going to do if fleeing is equal to false, then continue. We will set fleeing to true, so we don't run this part multiple times. And then we will set my face dot texture equals http www.roblox.com/asset ID equals 258192246. Hopefully I typed that right. I probably should have had that prepared beforehand, but whatever. My human walk speed equals 25. So we are going to change our face to a scared face, essentially. He's going to be very sad. And then my human walk speed 25 will make it so he's sprinting around. So that will be good. Next we'll do a repeat loop here, and we will wait 1 second in between, because we want a 5-second countdown, so we'll wait 1 second so the countdown will be good. Then we'll just do flee countdown equals flee countdown -1, so redact that, count that down every time. And then we will do until flee countdown is less than or equal to 0, or my human.health is less than or equal to 0. So until the countdown has reached 0 or we have died, then we will keep looping through here, and we will keep the sad face on and keep the walk speed at 25. This flee function can be called multiple times, and this will just reset the countdown. So every time we get hit or something, this will reset flee countdown back to 5 seconds, and then it'll wait another 5 seconds until we can start walking again. But since this has this boolean here, we won't run this part again, but this loop will continue running, and this flee countdown value will update within the loop on a separate thread. So that will keep the that'll just update the loop essentially to run for another 5 seconds if this flee is called again. Okay, so next here we are going to do if dead is false, then continue. So we're just going to double check and make sure that we haven't died, because if we have died, we don't want to change the face or anything. So if we are still alive, then we'll go ahead and update our face texture to rbx asset textures / face.png. And then we will set our human walk speed is back to 16. The normal humanoid walk speed. And then after that, we will go ahead and set fleeing is equal to false. Okay, so all of that should be good. Next thing we will do is do myHuman.died connect function. I think I spelled something wrong. There we go, function. Enter, and then we will do myFace.texture is equal to http www.roblox. Let's get a quotation mark in here, not mess this whole thing up. .com/asset ID equals 154.26038. Okay, should be good. And then we will do dead equals true. So we will flip that boolean to make sure our face doesn't change again. If we already have the dead face, then after this cools down, we will just, keep the same face on, because we will already have it set using this texture essentially. So that will keep our face dead. And then we will just do a 5-second for the respawn time, and we'll do clone.parent equals workspace. We'll do game, get service, debris, add item, script.parent, 0.1 second delay there. Should be good. Okay, so simple enough for the handling our character when we died. Next, we will do the most important part of this, which is going to be myHuman.health changed. Then we will call function, and we'll call variable in here. Okay, so health changed event. So whenever our character's health changed, whether it goes up or it goes down, this function will get called, and it will tell us what our health is at through this variable here. So we only want to change our face and run away if our health goes down. So we will do a check for that. We will do if dead equals false. So only check this if we are alive. And then we'll do if health is less than old health, then we will flee. Okay, so if our new health value is less than our original health value, then we will flee. And then down here, we will update old health to be health. So if our health goes up, then we will ignore this part, but we will update our health if it goes up. Okay, so that will call flee. And then we will find the threat or whatever and run away, change our walk speed and face and all that good stuff. So with the health changed event, the reason... never mind. Just continue here. We'll cut that part out. So next thing we'll do is set up the while wait loop. So we'll do while wait do. We'll do if fleeing equals to false. But actually, let's do one more check in here. We'll do if myHuman.health is greater than 0. Do that. We'll do else, break, end. Okay, so if fleeing is equal to false, then wander. And then we will wait math.random 5 to 15 seconds after we're done wandering. So that should be pretty much done. Not bad today. Only, 133 lines of code, which is pretty easy for, a yellow Mustang video. So let's see. Let's see what we got. I already see errors. What is this? Health change is not a valid member. It's health changed. Past tense. Okay, let's run this again. Okay, more errors. Oh, God. What did I spell wrong here? Health changed. 115 health. My human health changed. Oh, I see. I forgot the connect in here. I was so busy talking. Okay, so add the connect and then the function. So let's continue here. I really botched that part of the script, apparently. Okay, he's still standing here. Jesus. Jesus, I can't type at all. What is wrong with me? Async. Jeez, man. Alright, async. You guys are probably watching the video and you guys are like, thinking this guy doesn't know what he's doing. And I don't know what I'm doing half the time, but we make it work. Okay, there he goes. He wanders. Okay, he takes damage, and you can see he's running directly away from the zombie. Fast, and he got that scared face texture. He gets hit again. He gets hit again. Why? Why did he not do anything? All right, let's keep monitoring this guy. You see he's just wandering around. Happy, he gets hurt, and he runs. What is that? What are you doing? What in the fuck are you doing? Okay, so I'm going to get rid of these zombies, and we're going to get a guy out here that makes less noise in the output. So let's get some little Bigfoots out here, I guess, and they're going to cut up our guy, and we can better watch this. So he gets stabbed, and he runs to there, and then stops. Why? That doesn't make any sense. Why is he going to that point? What? What? Oh, because the unstuck function. Okay, yeah. So in the unstuck function, it needs to be my human move, not move to move. There's a big difference there. Move is based off a direction, and move to is based off a position. So he's now walking around perfectly fine. See, he's running away as fast as he can. And you can see the cooldown happened. His face changed. The walk speed went back to normal. And you can see he's happily going about his day. Smallfoot is running as fast as he can to come murder him. But he has no cares in the world. Okay, and he's running as fast as he can. Why does it look like the pathfinding is like not working? Probably because it's not. Let's open this again and see. I guess let's do some troubleshooting here. We'll do path successful, and if we make it past that point, we will print pathing. We'll just put pathing, I guess. Let's go ahead and continue. Again, I love troubleshooting. It takes so much time to cut from the code back to the game, back to the code. Okay. Okay. And still, these guys make so much noise. Oh my god. I feel like this get unstuck function is getting called way too much. Unstucking. That sounds great. Let's get rid of those guys. Dun, 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 dun. Can I please, do I have like anybody that like does not make noise? Do you make noise? Please tell me you don't make noise. I don't want to go find all your parent. Move directly. I feel like there's... Ah, it's you guys. You guys are making the noise. And you guys are making noise. Let's clean up our workspace. I don't want any zombies here anymore. Alright, we got our knight here now that is hopefully going to not... Where is this coming from? What is this? Grab. There are still zombies somewhere. Why is there so many zombies? Go away. Okay, thank you. Clear this. I do not want to see any more printing from anybody. Okay, unstucking. Right off the bat, he's unstucking when he's in a perfectly open area. Oh. No! nm.passstatus.success. Okay, fellas, there we go. Do not grow up and become like me because I'm awful at programming. Jesus. Okay, change that to success. Run it again. Okay, now you can see he's running away. Running away. Running away the best he can. Great. Okay. Now these figures are getting sliced up as well. Okay. It does look like he's stopping though, which is weird because if he's fleeing, he should be constantly moving. So let's get rid of these prints. This is how I debug my code, by the way. Okay, right here. So we had this commented out. We will get rid of the comment. And now this guy should be good to go. Every time he takes a hit, he should run away. And he's going to finish running away and then pick a random direction and keep running away to do his best to get away from the night. And then he cools down. And then he continues to do his thing. So then he dies, then he gets the dead face. And this face does not change until he comes back to life. And then he's all good again. And then the night comes back to come murder our amazing figure once again. And you can see our figure's having a bad day. But he is doing his best to get away from the night. Alright. Looks good to me. I mean, I guess all there is left to do is, I guess I can shoot him with a gun and be far enough away and just make sure the wander thing works when he gets shot. See, I got this thing I bought like years ago. Okay, there he goes. He's running around. He doesn't know what to do. Come on, buddy. I'm gonna get you. I'm gonna get you. I'm gonna get you. Oh man, what does my videos come to that I'm murdering these guys with a ray gun? Okay, and that concludes the figures civilian AI tutorial. I would like to thank you guys for watching. Remember to like the video and subscribe if you haven't, and I will see you next time.
Oh fuck, I can't believe you've done this. Oh fuck, I can't believe you've done this. Oh fuck, I can't